The line L has equation y equals 2x minus 3, and the curve C has equation y equals x plus 2 times x minus 4. Sketch the line L and the curve C on the same axis, showing the coordinates of the x and the y intercepts. And part B is show that the x-coordinates of the point of intersection of L and C satisfy the equation x squared minus 4x minus 5 equals 0. Hence or otherwise find the points of intersection of L and C. So to start with, I'm going to draw my rough axis. It's a rough drawing. It's not going to be absolutely straight. But if this was my x and the y axis, and then to draw the line y equals 2x minus 3, when y is 0, then 2x is 3, and x would be 3 out of 2, that is 1.5. So 1.5 is 1, 2, 3. So if each of these was 1, so this would be 1.5. This is 1 and this is 2. So 1.5 would be here. So if I just do 1.5, and then if x is 0, then y equals minus 3. So y-intercept is minus 3. This is 1, 2, 3. So this would be minus 3. So the line would pass through minus 3 and 1.5. So if this was a line, that's not correct. So I'll join one and this first, and then. So right, somewhat, this is the line L. And then we have to do the curve. So the curve is, well, it's y equals x plus 2 times x minus 4. So definitely the curve would pass through the x-intercept would be minus 2 and 4. So minus 2 is here, 1, 2. So that's minus 2, and 4 is 1, 2, 3, 4. So that would be 4. So that's where the curve crosses the x-axis at minus 2, 4. Curve C crosses x-axis at minus 2, 4, or I should say minus 2, 0 and 4, 0. So that's the two points of intersection with the x-axis. The next is, does the curve cut the y-axis, and what the curve would cut if the y-axis, if so to get that point, if I were to expand this the bracket, so we get y equals x plus 2 times x minus 4, and that would equal x square, not that would equal, we just want to deal with the x part. So if it is, it will be x square minus 4x plus 2x minus 8. So that would give me x square minus 2x minus 8. So this expression, so you see if x is 0, so now we can do, if x is 0, then y would be minus 8. So the curve cuts the y-axis at minus 8. So 1, 2, 3, 4, 5, 6, 7, 8. So that would be minus 8. So it will cut the, that's the y-intercept. Next, we got to find the turning point of this curve to be able to draw it. So to find the turning point, we are going to square this this expression. So it will be x square minus 2 times 1x plus 1 square minus 8 minus 1. So that would be x minus 1 whole square minus 9. So then the turning point of the curve would be, now before the turning point, I say I have to determine that the shape of the curve is U-shaped with a minimum point because the coefficient of x squared is positive, and the minimum point is going to be when x minus 1 whole square is 0. So y would be x minus 1 whole square minus 9. So the minimum point would be when this is 0, y is and this would be 0 when x is minus 1. So we can say x is 1, sorry. So the minimum point would be x is 1, y is minus 9. So 1 minus 9, 1 and minus 9. So this is minus 9. 1 minus 9 would be here, not 9, minus 9. So this is 1 minus 9. So I think now we can draw this this curve. So it would be and to draw this, the turning point. So if I were to go through 4 and so it's somewhat like this. If this was a curve, it's my freehand drawing, it's not the best, but yes, it would somewhat look like this. So this is the curve C, and that's a line L. So we've done that. We've done the parts A completely, and the part B show that the x coordinate of the point of intersection would be this. Now for part B, now this is part A. Hold on. That's what the curve would look like. For the minimum point, for the point of intersection, we've shown the points, the x-intercept where the curve crosses the x-axis, and we have drawn the line as well. So now is the next part for part B. So I will erase this. So it's easier to do, work it out. It's a bit, you can forward the video, to maybe make it go a bit faster. So then what I'm going to do is, for the B part, show the x coordinates of the point of intersection. So to find that, you'd have to write 2x minus 3 equals, you have to remove the brackets for this one, and that would be again x square minus 4x plus 2x minus 8, and that is x square minus 2x minus 8, 2x minus 3, and therefore you can say x square minus 2x, you say therefore 0 equals x square minus 2x, so minus 4x minus 8 plus 3, or therefore x square minus 4x minus 5 equals 0. So this is the equation that you would get if to get the point where the curve crosses the line L. So if we now the next part, to find the points of intersection, all we have to do is to solve this. So that would be x squared minus 5x plus x minus 5 is 0, and from there we get, if I put it up here, it would be x times x minus 5 plus 1 times x minus 5 equals 0, so x minus 5 times x plus 1 equals 0. So this would be, so x would be 5 and minus 1. So then this point would be minus 1, and you see surprisingly that is minus 1, and this point is, it's not exactly 5, but we can stretch it, and this is 5, but so it should have been a little bit moving towards the right. So the point is, this is the point of intersections. If I can stretch it to here, like this is the curve, so this is the point of intersection. So it would be 5, and the x coordinate would be 5, and here the x coordinate would be minus 1. So if x is minus 1, what is y? So y would be 2 times 5 minus 3, that is 10 minus 3, that's 7. So that's a bit off in my drawing, but it doesn't matter. So then the point would be 5, 7 times 5, and the other point would be y equals 2 times minus 1 minus 3. So that would be minus 2 minus 3 is minus 5. So once this would be 5, 7, and oh sorry, I was pointing to the wrong ones, but then this one would be minus 1 minus 5. Oh, this seems to be right. So minus 1 minus 5, and this is going to be 5, 7. Yeah, so yeah, it was a bit off here and there, but I think finally I got the correct answers. So the points of intersection, it took me a whole 13 minutes to get the answer. So the points of intersection would be 5, 7 and minus 1 minus 5.